Right off the bat, why don't you write down alligator? Everybody write down alligator. The next thing we're going to do is we're going to look at what happens when you mix baking soda and vinegar. However, we're going to put a slightly different twist on it. If you've had any sort of chemistry before, you've probably reacted baking soda and vinegar. What we call vinegar is actually about a 3% solution of what's known as acetic acid. And its chemical formula looks like this. We're going to mix it with baking soda. Baking soda is a substance known as sodium bicarbonate. Let's find out what happens when we mix those two substances. All right, let's take a look at another experiment. In this fun, fascinating experiment, I have in that beaker in front of you exactly 1 liter of vinegar. So you can imagine that it smells really, really good in here. To that 1 liter of vinegar, I'm going to add an old favorite of chemists everywhere, baking soda. When I add the baking soda, I want you to observe what happens. So I'm going to add a tablespoon of baking soda to it. And as you'd expect, we get that foaming reaction, and you're saying, I've seen that a million times before, what's the big deal? If we're seeing that foaming reaction, what does that mean is being produced? It means we have a gas being produced. Specifically, that gas is carbon dioxide, but more on that later. Let's add another, and I'm making a big, huge mess here. And another. And I'm okay. So I've added quite a big bit of baking soda to my vinegar. Now I'm going to stir. But we noticed bubbles were being produced. So now I'm stirring up my remaining baking soda with my remaining vinegar here. And I'm going to want to add just a little bit more of my baking soda, which I know will produce some more bubbles here. I'll add it slowly this time to try to avoid a bubble over. And I'm not going to be successful there, but that's fine. The reason I keep adding the baking soda is to make sure that I'm completely reacting all my acetic acid. I don't want to have any acetic acid that is left unreacted. As long as I'm getting bubbles, that means there's some acetic acid that hasn't reacted. All right. There we go. That's about where we want it. And now what we're doing is we're going to stir and make sure everything dissolves. And then I'm going to begin applying some heat. I'm actually going to begin boiling this. And the reason I'm boiling it is I want to concentrate it. Let me stress, this is one of the big places where what I'm going to do differs from what you've normally done. If you've ever done baking soda and vinegar at home, chances are you have focused on just the reaction of your acetic acid and your baking soda to produce carbon dioxide. However, if you look at the elemental symbols that you have here, you have some carbon, you have some hydrogen, and you have some oxygen. Notice in this formula down here, we're missing our hydrogen. If we look at our sodium bicarbonate, or our baking soda over here, we have hydrogen that doesn't appear as a product. We also have sodium that doesn't appear anywhere in the product. So even though, if you've had high school chemistry, or have just played around in your kitchen, you know that carbon dioxide is produced from the reaction of your vinegar and your baking soda, but there is also something else produced. As a matter of fact, there's something else produced. What we want to do in this experiment, and what I'm going to do differently from what you may have done before, is I am going to figure out and show you what the other products are. What are those mysterious other products? In order to do this, I'm going to have to heat my solution. So I'm going to apply a little bit of heat. And the reason I'm going to bring the heat is I want to drive off excess water. When you boil water, you convert water from a liquid to a gas. So I'm going to remove water from my acetic acid mixture, from my vinegar, sodium bicarbonate mixture, by adding some heat. So that's what you're getting ready to watch me do now. Remember, whenever you're doing something at home, find a procedure. I have not given you a procedure. Remember, don't do this at home, and anytime you use heat, you're adding an element of danger to an experiment, which is perhaps why you may not have done this in grade school. All right, so let's go back to the live action. So I'm going to try to boil away a lot of the excess water that I may have present. All right, and we're going to pause it. I know you'd love to stay and watch the exciting process of boiling away to concentrate, but I'm going to stop it, pause it, and we'll come back once I've gotten everything nice and dissolved and concentrated. Alright, and as I'm letting it heat, I should be watching it a little bit more closely. Somebody came by, and I got distracted, and I committed one of the worst sins you could ever do in chemistry, and I left something on heat. And after I came back, I had a success and a failure. I'd removed all the water. However, after I removed all the water, I was left with one of the other two products that we were interested in. If you look, you see a collection of really dirty white crystals. These dirty white crystals are the other product that you, or one of the other two products that you get when you mix your vinegar and your baking soda. These crystals are a substance known as sodium acetate. So if we go back to our basic chemical reaction here and try to figure out where those dirty white crystals are coming from, and what is this sodium acetate that I speak of? Well, we've got our baking soda. Well, let's start with our vinegar. We have our vinegar. And then we have our baking soda, or sodium bicarbonate. When we react them, we know we get carbon dioxide. We already saw that gas produced. And that carbon dioxide that's produced when we react the two, that carbon dioxide actually comes from your bicarbonate over here in your baking soda. These crystals that we see over here, these sodium acetate crystals, they actually come from taking the acetate part, this part of the vinegar and white here, and reacting it with the sodium from your sodium bicarbonate. And they form those white crystals that we're looking at there in the picture. Now, I promised you that you'd have two other products. What about the other products? Well, if we look at this red portion right here of sodium bicarbonate, of our baking soda, that's CO3, as in it has 3 oxygens here. Now wait a second. If it has 3 oxygens and carbon dioxide only has 2, what happens to that extra oxygen? Not only that, but we still don't have any hydrogen in our products. And we have a hydrogen there, and we have a hydrogen over here. Well, it turns out that that hydrogen and that hydrogen get together with one of the oxygens from bicarbonate and form water. So, we could say that vinegar plus baking soda produces three things. Carbon dioxide, the gas we see bubbling, sodium acetate, the ugly white crystals, and water. If we wanted to write it in the form of a chemical formula, I feel like I'm on Jeopardy. Please put things in the form of a question. Oh, by the way, speaking of questions, I forgot to tell you to write down something else. Why don't you write down turtle for me? Go ahead and write down turtle. Everybody write down turtle. Thank you. If we wanted to write this in symbols, we'd have our vinegar, plus our baking soda, and it produces those sodium bicarbonate crystals that we saw, plus, I'm writing too big here, carbon dioxide, and water. And those, hopefully, those white crystals are perhaps the first time you've realized that something other than carbon dioxide is produced when you form the burping bottle or perform a volcano. Now, I'll be honest. Because I left my experiment, I didn't get the effect I wanted to. If I had taken my 1 liter of vinegar, reacted it with my baking soda, and then reduced the volume to a volume of about 200 milliliters, I would have what's known as a supersaturated solution. A supersaturated solution is where there's too much solid trapped in the liquid. And when we look at a supersaturated solution, it looks just like a normal liquid. So what I did was I wound up repeating the experiment, and this time I didn't get distracted during my heating process. I repeated the experiment, and this time because I was watching everything and not getting distracted, I got a nice clear solution like you see here. It has a little bit yellowish tinge to it, but it's a solution of a liquid without any white crystals in it. And because I had just finished heating it and it was super hot, in order to make it super saturated, I had to lower the temperature. So I put it in the laboratory refrigerator to cool the solution down. As it cools carefully, it traps solid in it. Behind the making of a supersaturated solution is a quick little property. Hot liquids can trap more solids than cold liquids. So I had a hot solution of my water with those white crystals, right? I then cooled it by placing it in the refrigerator. Now, that cooling process kind of freezes all the molecules in place, leaving the solids sort of suspended in that liquid. Watch what happens when I take this clear liquid out of the refrigerator. Right now it's clear. You see just a few crystals floating in the top there. But now I've shaken it, and you can see that I've got white crystals beginning to come out there on the bottom. Now more white crystals are forming, and it looks like it's snowing. Matter of fact, now you see white crystals forming on the side of the beaker. And now, where my solution was previously nice and yellow and clear, I've got crystals all over the place. And I can't tell you how happy this makes me. This is actually a very hard thing to do, to make a supersaturated solution where it looks clear, and the second you disturb it, the crystals form by either shaking it or twitching the side of the glass. If you've had high school chemistry, your teacher may have done what's known as the snowstorm demonstration to demonstrate. This is a homemade version of it. This is the exact same reaction, but homemade, making the sodium acetate, which are those crystals that we're seeing all over the place, from scratch. It took me 3 attempts to get this to work over the course of 2 different weeks. So I can't tell you how ecstatic and what a personal victory it is to get that sudden release of crystals from a supersaturated solution. So in other words, if you try to do this at home following the directions posted on Blackboard from an internet site for which I take no responsibility for, you may not get it to work. I mean, in terms of forming the crystals like that. Now, if you boil off all the water, you're definitely going to get those white sodium acetate crystals that I had in the picture on the other slide a few minutes ago. But in terms of getting the sudden formation of crystals like that, that really does take a lot of work and a little bit of art. So, ta-da! Why don't you write down snake? Write down snake. That's it.